Awesome. Well, welcome everyone to the interview today for our Gold Nuggets Humanitarian Engineering interview series. Today we are going to be interviewing Dr. Josh Sharp, and I'll give him an introduction in just a moment. So for those of you that are in attendance right now, we are going to kind of go through some questions and ask Dr. Sharp obviously these questions for the interview, and then by the end we'll do about probably a 15 or 10-minute Q&A. So if you have questions throughout, please just hold them until the end so that we can make sure, I guess, we use our time as efficiently as possible and it's as smooth as possible as well. Awesome. So the interviewers for today are me. My name is Allison Palmer. I am a junior here at Mines in the BSE program, so I'm studying engineering with a focus in community development. I'm also a Schultz Scholar in the Humanitarian Engineering department, and I've also had a class with Dr. Sharp, so that's kind of how I got him to do this interview. And then also we have Evelyn Lundeen joining us today. She is a Mines alumni. Or an alum, and she was in the Humanitarian Engineering department as well. And she did a lot of research with Dr. Sharp throughout her time here at Mines. So that's also how we got her to be here today. So hopefully we can have a really awesome interview. I'm very excited. Cool. All right. So Dr. Josh Sharp, thank you for being here. I really appreciate it. I know we all do. I know we're very excited.
Thanks for inviting me.
Yeah. So to give a little bit of an introduction, Dr. Sharp is the director of the Hydrologic Science and Engineering program and an associate professor in the Department of Civil and Environmental Engineering here at Mines. His work focuses on water quality and meets at the intersection between environmental engineering, microbiology, and hydrology. He has worked in various parts of the world, including Switzerland and Peru, and his research has been recognized by many prestigious agencies and foundations. Today, we'll be talking about his career path, research work, and thoughts on his project's social and societal impacts. All right, so first question for you, Dr. Sharp, is can you just tell us a little bit about yourself as well as how you got to where you are today?
Yeah, sure. So I was lucky. I grew up in a small town, in a small state, with a really supportive network. And so I think what I lacked in terms of maybe exposure was made up for in terms of opportunities. When you live in a small town, things like your mom being your high school biology teacher happen. That has its own awkwardness, but it also kind of puts a burden on making sure you know your stuff. It also led to all sorts of opportunities like science camps, creativity camps. Since I was in Delaware and there weren't that many people, it was easier to get representation from senators. So Joe Biden actually sponsored me to go to Japan when I was in high school. And I just generally grew up in a really supportive community that helped to kind of help me get to where I am. And so I went on to undergrad, had some great research experiences there. It's part of the reason I'm so committed to making sure they're good research experiences for undergrads at Mines. It really helped to influence what I do.
Software development is learning, but your
company is. So I did undergrad, did research there, got involved in some research opportunities even during the summer in undergrad, which is really cool and a nice complement to more traditional jobs, which I also had as I was growing up. I grew up in a resort town, so it was really easy to get a job as a teenager. After finishing college and that research, I took a little step away from the university for a while and worked in the oil fields actually, but was able to sort of negotiate an intermediate internship in hydrology with a research consulting firm first. And again, I was really lucky. When I graduated from college, the economy was booming. It was super easy to get a job. You could kind of pick and choose, and you could even float a little bit. So when oil prices tanked, and I knew I didn't want to do that for that long as a field engineer, I went back and worked at the US Geological Survey as a researcher, and then went on to grad school. So I took about 2 years between undergrad and grad, and and really got a nice focused chance to see a bunch of different perspectives ranging from industry to research to help sort of hone my interests. I lived in the Bay Area in California for grad school for quite a few years, and then relocated to Switzerland for postdoctoral work in environmental microbiology, and then landed here at Mines a little over a decade ago, where I've been ever since. So I guess that's kind of how I got here.
Awesome. Yeah, no, that's a great kind of like well-rounded story of, here, I guess, in undergrad where all of us are right now, and then being able to see like kind of your whole arc, to where you got to today is very cool, especially because it took you, it looked like from like high school or to Japan and then like to undergrad and then kind of like all over the place and then Switzerland. And that's, I don't know, it's very cool that you were able to have all those experiences before even, I don't know, before getting here. So it's very cool. Thank you for that. Could you tell us a bit more about your research focus and how you kind of explained how you got into the particular area of work, but I guess more specifically, the research that you discussed in your bio and that you kind of focus on now as well.
Okay, cool. Yeah, so I mean, research in our lab sort of looks at this intersection of microbial processes and water. And I think lots of times when we think of microorganisms in water, we think about the bad stuff, right? We think about the pathogens sort of that we don't want to drink, and we don't. But I tend to think a lot more about microbial processes and how microbial metabolism or outcomes can influence water and hopefully influence water for the better, right? So I have my little background of a wetland here as inspiration. And the idea is if we understand what microbes do, we can facilitate processes that are a lot more sustainable than, say, we might do in a more traditional engineered system. So microorganisms are amazing at removing nutrients. They can break down trace organics that are really hard to break down in more conventional systems. They can facilitate the immobilization of metals, toxic metals like uranium or chromium or even arsenic. Conversely, some of their processes can make water worse. You can mobilize metals just like you can immobilize metals if you can't control processes. And we saw some really sad examples of that in Bangladesh and other places, in the past decades. So we tend to think about sort of those types of processes, and we try to inspire or we try to derive inspiration from nature to think about how we can manage and engineer, in particular, natural treatment systems. A sort of parallel theme of research in my group has been looking at this same theme, but more along the lines of climate change and ecosystem disruption. And so in this case, we've been thinking a lot about tree mortality up in the mountains. When I first moved to Colorado, the bark beetle was a huge issue. If you drove up the I-70 corridor, all the trees were red. And people were thinking a lot about fire. They were thinking a lot about real estate values, but they weren't thinking as much about water. And when they were thinking about water, they were really just thinking about whether or not it was impacting water budgets. And so we started to think a lot more about water quality and what those, watershed services and ecosystem services might mean for the water when those trees were dying, and found that indeed it does potentially make our water worse because when we take that water and chlorinate it, we were sort of changing the structure and the quantity of organic carbon. And in turn, potentially jeopardizing the health and well-being of people in these sort of small mountain communities that receive that water. So that's a little bit about my research. I think there was another part of that question, right? Was it how did I get there? Or
Yeah, it was just how you got involved in that particular area of your work.
Yeah, okay. I think it goes back to background and experiences, right? So when I was in undergrad, I was fascinated by the idea that microbes effectively work for free. And they don't work for free, you have to feed them a little bit, but it was pretty cool that you could sort of, in a non-invasive way, facilitate the bioremediation of contaminated groundwaters. And I think that's what got me really into it. And I had a research experience when I was in college in the summertime when we were working on understanding oil degradation from oil spills. It was right after Exxon Valdez, which was this huge catastrophic sort of oil spill up in Alaska, trying to understand those processes. So I think that got me really excited about it. And then through sort of a synergy and convergence of different processes, I started to sort of expand that scope, and have always tried to make sure that it's locally relevant and relevant to where I live and sort of the problems that I see and we see around us.
Awesome. Yeah, no, that definitely helped helped kind of narrow, yeah, like where I guess where all of it kind of came from. You know, you said that that experience that you had helped you to see that, yeah, this kind of work would be interesting to you. So that's very cool. Um, let's see. Okay, so how would you describe the relationship between your work, which can be your research work or kind of in a general sense, or the very specific, you know, projects you've worked on, the relationship between that and people?
I mean, I think that I like to connect my research and my teaching to at least what I consider to be societally important issues. Right. And so teaching, a great example of that is the stuff we do in field session, where we partner with nonprofits to look at themes like urbanization and legacy mining, on how that impacts water and land, and try to get students out sort of engaged in understanding the problems and finding solutions, you know, within all the constraints we have. In research, I do the same thing, and it's not that hard kind of in the domain that I work in, because I work in this kind of intersection of, as you said, environmental engineering and microbiology and water. And these are all super important societal issues, right? If we think about water supply and sustainability, if you live in a place like Colorado or in an arid region, it's abundantly clear. When you have a dry winter like we're having right now, and you have drought sort of threatening this next summer, people tend to think about this more. So that connection's there. When you do work like in microbiology, it surrounds us, right? Right now we're in the middle of an epidemic, and this is a viral epidemic, not a, you know, not bacteria per se, but that sort of relevance, that sort of daily cognizance of how that works, I think, is a little more abundant there. And then the environment. I think we're all acutely aware of our environment, some more than others. But as a society, I think we see the value of the environment for our health, well-being, our long-term livelihood. And so I think it's easy to sort of connect that to relevance. And so I think I try to keep those themes in mind. And I think those themes help to inspire the type of work we do in our group, and the type of teaching I do too.
Yeah, so that kind of leads into my next question, which you answered a little bit. But as both an engineer and a scientist, and a researcher and all of that, do you have a set of values that you really work by in regards to, you know, your research, and all of that?
Yeah, I mean, I think in life, I believe in working hard and playing hard. I think it needs to be fun. I think you need to enjoy what you do. And that's part of the reason why I'm in academia, probably, rather than doing some other things. I mean, it's just a really stimulating environment. You get to be surrounded by really amazing, engaged people, students and faculty and staff. That's really cool. I have a lot more intellectual freedom to sort of pursue my passions, and to sort of focus what we're working on towards what I think is environmentally relevant, and sort of think about a vision of where I would like to see things in the future. And so those are all really meaningful ways to do it. And I was very intentional, I think, in choosing this profession because of that. Those were things that were really important to me, much more so than retiring at the age of 55 or something like that, right? Because at this rate, I'll never retire. But it's a lot of fun to sort of do what I do.
Yeah, so I noticed in part of what you said there is that one of your values really is making sure that you're working by making sure that the work you do is environmentally friendly, kind of, you know, like really for the environment, obviously, in your work. I'm curious to know, with that, and then connecting kind of one of the questions that I asked, I think my previous question, when you're doing research and preparing proposals or getting funding for all these types of research, How much do you and your team consider the human impacts as well as the environmental impacts in that proposed work?
Yeah, I think that's a super important question, and I think the two are intertwined. And I think the work we're doing in Peru right now is a great example of that, both in terms of the capacity building, in terms of collaborating with the university down there, as well as thinking about the sort of much larger sort of societal implications of what we're doing. And so when we started out in that work, we were thinking a lot about sort of water quality implications of small scale mining activities where there's almost no regulation, almost no oversight, in what that meant and how we could come in with solutions. And a lot of the technological, at least some of this, maybe they're not the best approaches, but we have a lot of technological solutions to this, but there's still a lot of societal barriers to implementation. And so we've been really careful to make sure to engage folks like Nicole Smith here at Mines in trying to understand what the opportunities and barriers are to adoption of different treatment technologies, and trying to figure out to say, natural treatment technologies might have more embrace by those communities. They understand the implications of some of those actions on their livelihood than maybe more aggressive engineered technologies. It might be more likely to work. There's a pretty classic example, and I'm sure you're aware of it, in humanitarian engineering, where environmental engineers run to some developing country with the best of intentions and build a wastewater treatment plant because the water's polluted and you have to build a wastewater treatment plant. And if those same engineers come back 2 or 3 years later, if there isn't sort of a way to perpetuate the maintenance of that wastewater treatment plant and its operation, it's usually silted up and it's no longer in operation, right? So you've got to have local and community buy-in to make these things work, and it has to be meaningful to local communities to make it work. And that's something we struggle with as a discipline massively. So yeah, you absolutely have to maintain a social component to this work. And that's just one example, right? It's true in the US too. We have to value these processes to move them forward. And we have to have a structure that values these processes and outcomes, whether it's carbon credits or cleaner water or whatever else.
So I heard in there that you said that in your discipline, you feel that you struggle with, having these perspectives maybe throughout the field. And I don't know if I heard that quite correctly. But I'm curious, to know, I guess, a little bit more about that. And it seems pretty clear, I guess, to me that you think obviously that all of this is very important, both to the environment and the social and society and communities that you're working in and all of that. I'm curious to know if other people in your field also feel the same way about that.
I can't speak for everyone in my field, right? I think a lot of us see this challenge. Another great example is direct potable wastewater reuse, right? We can treat wastewater, and we can treat it fairly safely. We don't know everything. We're still finding stuff in water that we maybe shouldn't have in there. But there's a huge social barrier, that this sort of toilets to tap conundrum, right? Where people don't necessarily want to drink toilet water, even though this might be a really nice way to locally close a water loop. And so, yes, I think that most environmental engineers certainly see this sort of something that we need to work on is sort of more social engagement in connection with technological advancement, right? You can't have one or the other. It's a discourse. And a lot of it's about getting people comfortable with technologies, or just as important to get folks comfortable with technologies or see the value of technologies as it is to develop better technologies. So I don't think you can have one without the other if you want to really implement change.
Yeah, I completely agree. Go ahead, Evelyn.
Oh, yeah, I was just going to hop on. I think you kind of touch a great kind of crossover to point what I was hoping we could speak on a little bit. And that's we've identified kind of how the research that you work on impacts people. But I was hoping we could talk a little bit in more detail about the specific types of communications that you have as a researcher with the public at large, or with the kinds of communities that your work effects. You mentioned the pine beetle research. That's a water source for more rural mountain communities. Have you had any experience trying to communicate those potential risks or impacts to those communities? Is that a role that has been placed on someone else? And I want to open that up to you. You can speak on any of the projects that you've worked on, but where do you see that intersection between doing the research and communicating those ideas or communicating those findings to the public?
Yeah, so the pine beetle is a great example for that. So in part of it is we were lucky enough to have National Science Foundation funding that sort of valued that interface. And so we actually had a series of workshops, first with small water municipalities. We sort of had these, what we call beetle cafes, and we bring them in at sort of existing conferences, and we convene this sort of session to work on what they saw as the most important issues, and then understand how they interpreted the findings that we were seeing in association with a sort of increase in disinfection byproduct formation potential. We did that for a few years with water municipalities. I think we increased cognizance there. It was good. I think we could have done better. We also had some small communications in local newspapers. I think it was the High Mountain Times, I can't remember the name of it, up in the mountains. And then we started switching some of our focus to elementary school, mainly outreach, and developing modules to get students in elementary school through outdoor lab and other mechanisms to start to understand some of these problems, to sort of better understand the value of forests, watersheds, and for water quality. In both cases, in one case we were reaching out to practitioners, providers of water. In the other case, we were reaching out to children who will, presumably help find some of the solutions of this and also be consuming water in the future. And we thought that was an important way to approach that. So yeah, I think the communication is super important. Could we do a better job at it? Absolutely. But I think these are two examples of how you can move in that direction. And with the wetlands project, again, we've had these themes of communicating with children more broadly as part of an engineering research center, as well as interfacing really strongly with industry to try to see if we can actually increase communication and adoption of these technologies. I just gave a talk, maybe a month and a half ago, and working with sort of a conglomeration of nonprofits and utilities in the San Francisco Bay Area, and they're going to construct a wetland like this with some new adaptations based upon some research that we proposed, as well as some other wetland folks, to actually take these to address storm surges, in addition to sort of treating secondary wastewater. And so that'll lead to some really close, new sort of development in that area. Next week, I'm going to give a talk up in Alaska via Zoom to talk a little bit about our findings with the bark beetle in Colorado, because they're going through a huge issue right now with bark beetle mortality in Alaska. And water availability and supply are a little different up there. But I think it's important for them to understand some of the challenges we run into, some of the things to pay attention to. So yeah, I think it's all super important. So that's some examples of how we've tried to communicate our research and get different sort of stakeholders engaged in it. Beyond the classical writing research papers that 5 people read.
Hey, I read them. Would you say that overall you felt these were effective? Like, did you feel as though when you were holding these workshops and having that communication that you were getting something back? Or would you say it felt, did it ever feel kind of one-sided, and how might you have adjusted to try and change that in the future?
Yeah, I think it got traction. Maybe not as immediate as I would have liked. But a few years ago, I had someone from Trout Unlimited come to talk about some of the bark beetle stuff we've done. And so they'd clearly been looking at the papers, and they'd clearly been thinking about, in this case, actually metal mobilization associated with the bark beetle. And I think they misinterpreted some of our findings. And so it was kind of cool to continue that discussion and that communication. But that was a really cool one, where it was a group that I hadn't actually directly reached out to, and they directly reached out to us, having looked at some of our research. With the municipalities, I think there has been a shift. I don't know if we influenced it or it was sort of a larger influence, but maybe we helped to create some of that foundation, where they are thinking a lot more about ecosystem services and watershed health. Denver water is a great example of that now, as they're thinking about it, and fire's pushing this issue as well. But I think they're thinking a lot more about ecosystem disruption and how it might impact their water. And so I like to think that by getting in there early and stirring the pot a little bit, maybe we help to sort of stimulate some of those conversations. And then as far as kids go, time will tell. I mean, in general, they're enthusiastic and engaged. And, if you can create, the next generation of voters and population that values these processes and values these thoughts, that's always a good return on investment. And it's important, right? I mean, we have a phenomenally polarized society right now, and we have some people who get some of these issues more than others. But the vast majority of the US population right now, for example, believes that climate change is an issue and we need to do something about it. More so than our political will, at least until recently, was willing to address that. So I think we're moving in the right direction. Is it always immediately gratifying? Not necessarily, but hopefully it is in the long term.
Is this type of engagement something that you've participated in and experienced throughout the entirety of your academic career, or is it something that's maybe been more prevalent in the recent years? Like, do you think generally as a field, has there been more of a push to engage in these types of activities, or has this always been a part of the work that we do?
Yeah, no, that's a super interesting question, right? Because there's this mandate for sort of scientific impartiality and not being too strong of an advocate, or else perhaps your research gets biased. And I remember sitting in undergrad and was watching a talk by a guy who just received the Nobel Prize associated with the ozone, or the sort of the ozone hole. And he made this comment that really pissed me off at the time. It was, well, my job as a scientist is to tell people what's going on. And it's up to policymakers to interpret that and do something about it. And I definitely see the truth to that statement, but I also think that as scientists and as educators, we probably should advocate more than we do, while also realizing that, getting back to the communication theme and the social interface theme, that there's a lot more to it than just the science, right? But, presumably people trust us, and presumably we're out looking for fact. And so we should do a better job both articulating that, as well as helping to steer folks towards what we think are meaningful solutions, realizing that we are a part of the puzzle and not the whole solution.
Yeah, it's certainly a tough balance, because I think we all like to perceive science as just pure fact and not necessarily on the moral scale. But I mean, I think you kind of went ahead and answered the other question we had, but I'll pose it anyway as sort of a philosophical step out. But, do you believe that scientific research inherently benefits humanity, or is that something that needs to be purposefully cultivated and integrated into the kinds of questions we're asking? And, where does that lie?
I think absolutely is an answer to both of those questions, right? And again, it's hard to escape the pandemic since we're doing this on Zoom, but I think that's a fantastic example of the value of basic research and letting scientists sort of pursue their passions, and funding that and supporting that and training scientists through research funding towards adapting and shifting towards a solution, right? We developed a vaccine to COVID, meaning societally, nationally, internationally, in like a month. The virus was sequenced in 2 weeks. When I was your age, we were going through the Human Genome Project, and there was this huge duel, and it took years to sequence a human genome. We can now do this. You can swab your cheek and send it off to 23andMe. Heck, people do it for their dogs now. I mean, our ability to do this is because we were pursuing basic science, and we were training and putting money into training the next generation of scientists, which then led to this amazing synergy of public-private partnerships, right? We had private companies working on developing vaccines with public funding, but it was all supported by are societal investments in basic research. So that's one example, but there's so many of them, right? The internet's a great example. And there are gazillions of other ones. And I think it's often hard for individuals to see the connection between the money we put into research and all of the societal good that comes out, because you can always cherry pick and look at one project and say that has no relevance to anything, right? But if you think about the larger mission of increasing inquiry and not knowing where basic research goes, and also the synergy of integrating basic research with applied research and application and industry, and training, then I think the dividends are immense. It's what made this country so amazing, kind of post World War II. And I think it's something we've lost track of a little bit in the last couple decades. And it's easy to point a finger because it is an investment, but I think that the yield on it's massive. Do we need to do a better job of calling out the value of science and engineering towards society in schools and on a daily basis? Absolutely. And do we need to make sure that we see those societal connections through programs like Humanitarian Engineering, the Schultz Scholars? For sure. I think that's super important as well. So yeah, I think spot on to both of those. We need to do as much of it as we can. And I think society needs to see this value more and have reminders of it more often, because it's easy to glance over it, but it's so important.
Do you think there are key elements or methods that we are integrating right now, or we could include in the way we look at engineering education to kind of help further that mindset along? Or
I think being cognizant of it's huge. I think having programs that specifically embrace and reward it, I think is super important. And just, pointed at you guys because this is a lot of what you're doing. Can we do a better job? Sure. I mean, even just thinking about pedagogy, like folks learn better when they can connect it to tangible problems and local scenarios and place-based solutions. And we've tried to incorporate that a lot, in our field methods-based courses, where we do that. But that's what really, it leads to connections, and it leads to relevance, and it leads to better learning, and it leads to better societal outcomes. So yeah, we can certainly do more along those domains.
Great, thank you.
But it's a balance, right? I mean, you also need some basic foundation on which to build, and then come back and sort of realize the applications of that basics, those basics.
Is there a specific project of yours? I mean, I don't want to make I feel like picking favorite research projects is a little bit like picking your favorite child, but is there a research project that you've worked on that you're particularly proud of, the way that it kind of turned out and the way that it integrated, the concepts we've been talking about? The others, or?
Yeah, it's kind of like picking, I'm proud of them all, right? And I'm particularly proud of the ones we haven't done yet. Like that's the stuff that gets me really excited is, what we could do in the future. I think the examples that we've talked about, over the past 20 or 30 minutes, the ecosystem disruption, the natural treatment systems, I think those are both really cool because I think they integrate a lot of these different facets into them. And so, yeah, I'm super proud of those. I'm super proud of the students who've been involved in them, the outcomes that have come out from them, the work that's continuing on those. But all sorts of projects have a lot of fun stuff. This new work in Peru is super cool because we're continuing some of those themes in a very different domain. And there's also this sort of, this really cool idea of, working with universities down there to sort of increase their capacity to, really come up with their own solutions to some of these challenges as well. So it's all fun. It's all cool. It's kind of the neat thing about this job, right?
Yeah, with the Peru work that you're involved in, what kinds of additional challenges are there associated with working in a completely different country with a different culture and society?
Yeah, well, aside from travel, which is challenging right now, right? It's always hard to do place-based research if you're not in that place, right? So we've had to pivot and adapt, and the research infrastructure with our sort of sister university down in Peru isn't quite the same as the research infrastructure we have here. So I think we've had to get really creative in terms of how to do the most meaningful research by sort of integrating the strengths and talents of the researchers down there with our strengths and talents here. So for instance, rather than maybe doing direct sort of field-based analyses, we've gotten really resourceful and clever at sort of mining existing data that's down there to try to better understand what the environmental implications and pollutants are. And then we can bring that understanding from 6,000 miles away back to the laboratory here to actually run lab experiments and experiment, right? But then we'll try to take the insights from our lab experiments and bring them back down to and do things like build tiny, small versions of this wetland down there and treat actual river waters down there. So we can really sort of extend that. So it's a juggling act and it's a balancing act to do work that far away. But it also, in many ways, it mimics the same challenges we have here. We have plenty of mining impacted water in Colorado, right? So we can look at some of those challenges here and then transfer that insight to make sure that it's relevant down there.
Thank you. It just sounds like a very interesting project. I know it was kind of starting up as I was heading out, but what kinds of partnerships do you have with the local universities down there that you're building? Or what's the focus of those partnerships?
Yeah, so I mean, I think the focus of the partnership is just that. So it's the funding's coming from a mining tax. And so we work directly with UNSA, University of St. Augustine in Arequipa, and are paired with researchers down there. And so the collaboration is very much along the lines of we try to work with them to identify the problems, both their administrators and their faculty, or not their sort of research wing and their faculty. And then we try to create partnerships where we can work together to sort of build that. And I think another part of our goal is to help increase the research capacity down there through these research partnerships, which is really cool, right? Because they're traditionally a little bit more of a mining university, but they've got all these water problems. And so I think one of the things that where we've really made a mark is we've got them thinking a lot more about both the water supply and water quality challenges in that area. And I think through doing that, I think we're increasing their capacity to both understand and to potentially address those problems. So we're working with them on more robust environmental analysis, and then training them on some of these sort of treatment technologies that make the most sense down there. And they've done lots of great work looking at sort of low cost materials and how they can be used to treat metals. But that next step to scaling it up in actual experimentation and potential ultimate implementation still isn't quite happening at the same level there. So it's cool to help sort of work at that divide.
Great. Well, thank you so much for taking the time and answering our questions. I know we're a little bit ahead of schedule, but I figured at this point we would open it up to see if any of the other participants had questions before I just send you down a deep research rabbit hole.
Hi, I'm Kevin Moore. I've got a few, we could probably just have a long conversation. I hadn't fully formed a question, but this is almost urban myth. And some people have said, well, that didn't actually happen like that, but I didn't hear it, so it's not quite clear. But someone on campus said they heard it and told me. We had a mines graduate who was a keynote speaker at a meeting called Energy for Africa. And it was the lunch banquet or whatever. And the mines speaker talked about siting a dam to generate electricity to power a mining operation somewhere in Africa. And at the end of the talk, someone asked this gentleman, what about the local villagers who were displaced by this dam? And his reply in public, waving the mines flag, was, I don't know, I was paid to look at the rocks. All right, so this speaks a little to this notion that, well, we're doing good science and we're, I'm passionate about science. I don't really care about villagers. So, I mean, what's the reaction to that? I mean, I saw a visual reaction, and but let me just give like the counter answer of sorts. Is I mean, I have a cartoon on my bulletin board in my office. It's not really a cartoon, but it was a letter to the editor of Nature in 1898. A famous electrical engineer was criticized for using too much math in a paper written to Nature. And someone else, a mechanical engineer, wrote into a letter to the editor and said, look, if universities don't do useless things, who will? All right. And that's kind of a counter answer to the cringing at a graduate saying, well, I was paid to look at the rocks. I don't know about the villagers, right? So, I mean, this to me is a dilemma, actually, at some level. Or it takes education to get over what might seem like a dilemma. What are your thoughts about that?
I think you've articulated a larger dilemma quite well. I agree with much of that. I mean, it's obviously a cringe when an engineer says, who cares about people downstream of the dam that I helped build, right? I mean, it detracts from everything we think about if we want to make the world a better place.
Right.
The joke about, if, universities won't do useless things, then who will? I think links back directly to this, argument of basic inquiry and not knowing where it'll go. So yeah, universities in some cases should do totally, what we might see is niche useless things, and some of those turn into phenomenally useful things. I mean, another example is CRISPR, right? I mean, this is somebody trying to figure out a way to splice DNA in a different way, and it's led to now a Nobel Prize because we've realized just how valuable that technology is compared to classical sort of mutagenesis. Yeah, we need to follow our passions, but I think we always need to ground it in what it means. And genetics is a great example of that, right? It is, we start to tread on these, morally very, touchy subjects like, are we going to start to engineer or tweak human DNA? Are we going to change who's born and how? I mean, these are really morally complex issues that we can't lose track of. So you can't decouple morality from being a scientist or an engineer. I think that's a tragedy. And I think refusing to do so is a huge shortcoming, and it's hopefully it's a more antiquated response than the folks we're training today. I look at least.
Yeah. Well, yeah, I agree. And I hope in our educational processes, I think someone at Mines One Lucina likes to talk about the false dichotomy of technical and social. That they're not really unrelated. Mm-hmm. And in fact, they're often highly integrated, as you talked about with policy issues and other things. So at least if we could just let our students know, then that keynote speaker could say, well, I don't know exactly what happened, but I know that we had a unit in the company that was, dealt with that early on, right? Rather than just saying, well, I don't know. Yeah. I was paid to look at the rocks.
Yeah, no, it's in talking with some execs at mining companies, at least this was, a year or two ago, they said one of the biggest things they were spending time on now was sort of social license to operate, social implications, environmental implications. And at the time, this was right after some tailings dams had ruptured in Brazil. And so they were engaging in basically international efforts to basically pin drop every single tailings dam in the world. And tailings dams are interesting beasts, right? I mean, it's a way of disposing of waste rock and tailings and water in as minimally expensive a way as possible. There are better ways and worse ways to design these. And we have to think about the environmental, social implications, both of displacement when they're made, as well as what happens if something breaks, right? I mean, people lost their lives to that, and that's inexcusable. And so I think there is a societal shift in this direction. I think it's inevitable. I think it's happening. And we need to train people to think this way because it's so much more than just the technology.
Yeah.
All right, so if there are no more questions, if there are, please feel free to speak up now. But if there are not, we want to, end the interview and let everyone be on their way. Let Josh go do his fantastic original research things that he does. Thank you, Dr. Sharp, for participating and for being interviewed and being with us today.
No, thanks for the opportunity. It was great talking with all of you. Evelyn, it was wonderful to see you again. It's been a couple of years. So yeah, no, it was a lot of fun.